Well, that was annoying. Yes, I thanks QT for showing my email address there. Let me just double check. Yep, great, volume's on. As annoying as that is, we're back. So sorry about that. Anyway, I managed to get it working. Apparently, QT Designer was what I was looking for, so I just had to plug in the letters Designer and everything worked. Great, so we're here, and we have our little panel that looks about right. Uh, Also notice this push button. I'm sure we wouldn't know what to do without that. Okay, cool. So we wanted to add this functionality where L would be 1 less than N, right? So this is currently called line edit underscore L. I think that makes a lot of sense. So let's go with the flow and let's use that. I have to remind myself of how the code works, but I think we'll get there. Let me just remove these comments. I don't know if they're that interesting anymore. Electrons widget. That makes sense. We're binding events. Great. That's on the initialization of it. Can you see anything I'm doing? Probably not. Whoa. Let me zoom in a bit. Honestly, I could start a podcast after going to the toilet, taking a dump, drinking everything I need and eating everything I need, and I'll still need to do the whole lot again. Like right now, I'm like crucifying myself by not going to the toilet. But hey, uh, for the 0 viewers watching, I'm doing it for you. Okay, start operation clicked. That makes sense. Yet we're binding the push button to that starting of the operation. Great. What is this saying? It's saying uh, if there is if there's if the text does not equal nothing, do it. Otherwise, do it. Otherwise, do 0. Okay, that makes sense. Uh, so I suppose to find shell letters is just one operation of many. So this happens. Okay. Now I need to know when it's updated. No, I do not. I only need to know when the push button is clicked. Then I can reprocess. So this is going to be process N. And then we'll have process L. And this will be the L. Yeah, I think so. Okay, fine. This will be L and M. No, sorry. L will equal N passed as an int. I don't know how to do Python, by the way, so let me just Google that. Let me just Google that. Pass string as int in Python. Let me see. Uh, Representing integers in Python, an integer can be stored using different types. Two possible Python data types for representing an integer. Nice. Just give me the answer, please. It's okay, we don't need to know that. How to convert Python string to int. To convert a string to integer in Python, use the int function. Okay. So that's going to be like so. And it'll just be -1, right? Uh, ah, but this is a restriction. It's like a validation because I can put in other numbers. Yes, okay, so actually, I should say if L is greater than um, int n minus 1, then go to hell, essentially. So let's put another validation thing in here. Let's go validate L. Yeah, this Visual Code doesn't seem to help me as much as PyCharm does, though I just find it annoying having to have many IDEs. It's just anyway, validate L. So let's pass in n. Validate L with n, and that'll be n as an integer, and that will return a boolean. I think that's how you do it. Return. And it's going to be if n is less, if integer n is if wait, we need to pass in L here, and we need to compare it with n. So if the integer of n, if L as an integer is less than, then we are good. That's it. Yeah. That's that done. And then maybe we should have like a little error output if it's not. Likely a good idea. So let's think about doing that. Where should we put our little error? Now I suppose I could just fill in the output really, couldn't I? I mean it's a bit lazy, but I think it's fine for now. So let's do that. And I could say if validate if self dot validate L with n, and we pass the L and we pass the n. I have to remember this is not C# or C++. So if that's true, I want, if it's not true, then output is going to be something like error. Please, L is not n minus 1. L's value must be between 0 and n minus 1. Beautiful. Okay, let's recompile this and see what happens. So now, if I put in 3, all is well. But if I put in 3, 4 here, it should say, oh, it doesn't get there. So, what have I done wrong? Let us have a little play. So L is going in as 4, N is going in as 3. And if I step, into L is less than no, so if it's not, then it should go into there, and it does. And output is that, but I don't set it. Alright, fair enough. So to avoid that situation again, let's say another function, and we'll call set output message, and we'll take a little string. We'll call this the message, and we'll take that as a string. That is a type, good. And this will return void. I don't know, it doesn't do that, so it's going to be maybe none. And then this will be that, and this will be that. And this needs to go. Wait. What have I just done? plain text edit output, plain text. So we're setting it twice here. Disappointing. I don't think I meant to have done that. So let's do yeah, self dot set output message to shell letters, and then we'll go and correct it. You know, if it's not playing game, then we'll just go and put this out instead. Yes, and this I think is bullshit, so we need to get rid of that. And this, now that's interesting. So why was it join message, set output message, great. This one was just output to output, and then this one was setting it to the shell letters. The shell letters were just being joined by a comma. Ah, I see. So I actually want to do that as message, and that will be shell letters. Yes, and this will be nonsense. F5 to run it. Let's see what we got now. So we put in a 3. Okay, we're running. It's less than, so no problemos. And if I put a 4 in there, it should say, hey dude, what are you doing? Error, L's value must be between 0 and n minus 1. That sounds good to me. Cool, so we have that shaped up. I tell you what, whilst I'm here, let's see if I can get another version of my bloody email address up here by trying to push to Git. So I'm just going to add added L functionality with n in mind. Where do we push to? There are no stage changes to commit. Would you like to stage all your changes? Yes. And then I'm going to push those up. Are you going to give me a little prompt? No. And let me just check that that's gone up. We're good. Interestingly, I'm pushing as the wrong user, which is frustrating, but not that frustrating. So we're good so far. Next one. The magnetic quantum number m can be any integer between -L and +L. If L is 2, then it can be -2 to 2. Cool. That sounds alright to me. So the magnetic quantum number, validate m with L. Nice. Don't know what I just did then. M with L, M with L, and it must be M must be greater than right. So I need to know how to force something to be negative. I know the math absolute. So I guess you just put in a minus at math absolute, right? Python math absolute abs. Like a good use of abs. Just checking it's not part of an import that I need. I'm guessing it's built into the actual Python language. Looks to be. So let's do that then. So validating m with L, it should be that m is greater than the negative of absolute n, L, sorry, and integer m, which I think now should be cast because I don't want to do this twice. cast m as int. Oh, let's do m as int. Oops, oh my god, I can't type. Int equals that, and L as int equals int L, and then this, whoa, makes it a little bit less disgusting, I think. Yeah, and probably should do this as well. L as abs. Yes, or abs L, to give it a sense of belonging and alpha. So now we've got, yeah, so the input of m must be greater than the negative of L, or greater than or equal to. I think that's what that was saying. Disgusting. What is this? Okay. So if it's 3, it can be if it's, so if L equals 2, it's greater than or equal to. Yeah. Okay. Cool. Greater than or equal to negative L, and uh, and less than or equal to absolute L. We have an answer, I think. Now, what's going on here? Expected expression. Oh, yes. Right, that's how that works. And can we put these on different lines? Because that would be pretty sweet. No, I actually quite dislike the layout of Python, I have to say. I might change my mind, but I don't like that I can't do that on different lines. That's probably an aftermath of me being in these C-type languages so often, so I'll give it the benefit of the doubt. Not liking it though, not feeling good about it. Okay, well, now if this is false, process Mr. X, then error m's value must be between. Now that's interesting. I want information on this. I know that is interesting. I want information on this from this function, so I'd need to pass back an object with that information. That seems a little bit wasteful. Yeah, I suppose I could do the validation in here, well, the output message in there, and that would save the requirement to do that. So let's do that. And in fact, I think I might prefer that as well. Let's call this output. It's a boolean, and it equals that, and then we'll return the output. Well, let's call it result. I like it. And then I can do the if statement here, which I think I've just lost. Thank goodness, I'm so glad I lost that. Right, before I do that again, let me just see if I can set this a bit better. Yep, bool, bool, great. And then this is going to be exactly that. If this is false, then do this, otherwise return the result. And then same goes here. If this is not true, then error. Yep, okay, and then here I just want to call it process M, and this is process L. Yes. Okay, I like it much better. Um, now, um, this needs to give a different message. This will be m's value must be between negative like that, and this should be a string, and positive that, and this should be a string too. Validate m with L. Okay, great. Let's try that out for size. And yep, so pretty clean chat room as always. So if I do 4 here, we're good. If I do 3 here, we're good. If I do 4 here, we're not good. And if I do 4 here, we're not good. Ah, that's a problem. So this is not working. Validate M with L. Aha, I haven't. No, that's right. That's right. Sorry. Okay, push. We are here. The result is true. Even though L it is indeed greater than negative 4, but it is not less than. So that is not true. I've done something very silly here. So 3 is an integer, absolute L is an integer, and negative that is hopefully what I think it is, negative 4. So this is 3 is definitely greater than negative 4, and 3 is 3 is less than 4. Great, okay. And L, wait, L was 3, so this is wrong. Let me try it again. Sorry, I've missed something very simple. M is the one that we care about, so M must be greater than L, and M must be less than L, but M is 4, so why does it think it's 3? And that's because I've been passing in the wrong things here. Haha. Yes. M and L. There we have it. Let's see how we're rocking now. Wow, okay. I have to press F5 apparently. So now if I do 3 and a 4, that should complain. Should be false. Yes, we are good. And it will say error, m's value must be between negative 3 and 3. And if I put that, then L's value must be between 0 and 1, 0 and n minus 1. Now n is 0, so okay, well, that's fair enough. I guess we could do the actual output here. Why not, I say. So make it nice and easy. Result is L, the value must be between 0 and n minus 1. Let's put that in brackets, and put 3 positive signs for some reason. And this will be n minus 1, which makes me feel inclined to do this again. N as int, n as int, n as int, n as int, n as int. yeah, 0 and n minus 1. Don't know if that works like that, so but this should, okay, cool. Here's hoping we've got this finished now. So we'll put in a 4, we'll put in a 3, we'll put in a 2. Let's go muck up things. Let's go 4, minus 3 and 3. So put that there. Great. And if I do a 2, it must be between -2 and 2. Ah, that's interesting. Let me read this again. If n equals 3, then it can be either 0, 1, or 2. So it is n minus 1. But in this case, m is 4. So L can be 3. So this is failing. Let's see. L is 2, and 2 is less than 4. So this should be true, and so it should not get in there. And it doesn't. M's value must be between -2 and 2. I see, okay, I see. Here we go. Done. Now, cool. Let's just give a little bit more validation. Something like success. The success. Here is your electron output. Yeah, why not? That's good. Oh, I really like this. Okay, L's value must be between 0 and 3. Minus n minus 1. That sounds a little bit weird, so let's do something a little different. E.g., the formula is, the equation is n minus 1. The value must satisfy the equation n minus 1. I like it. And no need for those anymore. Okay, cool. Next step. Now we got to here. Now this is where I think something got quite complex quite quick. So, oh wow, uber close up to me. There's only one orbital in the n equals 1 shell, because there is only one way in which a sphere can be oriented in space. The only allowed combination of quantum numbers for which n equals 1 is the following. That makes sense because L must be n minus 1, and then 0 has no between values, so m must be 0. This makes sense. There are 4 orbitals in the n equals 2 shell, so maybe we should output all the orbital possibilities. So you can put them in, but if you have chosen an n value, then down the side it'll say all possible values, or just underneath the output. Now, that's interesting, and I like the way they've kind of laid out in an array, a matrix, my apologies. So if we strive for that, that kind of prepares us nicely for some machine learning because the tensors like to be in matrix form. So let's do that. So I just need to iterate over and produce all possible values from the chosen n value, and I suppose the chosen L value, because there is still a series, a set of possible outcomes that I can have, regardless of them being refined by the previous values. So let's do that. Where do I put that? Let's start with the output. Now we can fancy this up later, but I think just putting it in the output is fine for now. So, where do I put this stuff, and do I really like this here? I may need to clean this up at the end. I think this is a little confusing to have them all kind of seried up. And in fact, define shell letters, perhaps it makes a lot of sense to have this inside here now, given that the other ones are already like that too. Yes, let's do that. So if I F12 that, oof, gross. Okay, let's pop that there, and I think that's it because shell letters already exist here. We are done, and we have a nice little series of things happening now. Interestingly, does this actually return a list of string? It does. Okay, great. The type head's there. Let's remove this. No need for it. Right. Save point. Let's do that. N, L, and M are set out. We will next define the matrix of all possible values. For M, for L, and then M. Boom. Okay, and we'll push that up. So, cool. That's a good position. What I'm going to do is I'm going to stop here. I need to go and have a quick toilet break. I will be back, and I will try to sort out the other video because I've had to take that offline. I just need to like blur out details. Yeah, pick up from where we left off here. So see you in a bit, and I'll see you in a